The polynomial function p is given by p of x equals x plus 3 times the quantity x squared minus 2x minus 15. Which of the following describes the zeros of p? So before I even look into anything, if I want to find the zeros of p, let's see if I can factor that any further, and we'll set that equal to 0. I have x plus 3. I need to come up with two numbers that add up to -2 and multiply out to -15 and -5 and +3 should do the trick. Now what we have here, if I want to go one step further, is we have x plus 3 squared and x minus 5. Okay, so my zeros are going to be -3 with a double root, or some people say multiplicity of 2, and then we have +5. So I have two real roots where I repeat myself, but I wouldn't actually graph that. It wouldn't look like that. So when I look at this, p has exactly two distinct real zeros. That's my correct guy. Okay, p has 3 distinct real zeros imply that I have 3 zeros and they're all different numbers, and that's not the case here. Okay, I do have 3 factors, but 2 of them repeat, so I only have 2 real zeros. And this is talking about, do I have an I? Do I have complex numbers? No, nothing like that. My answer is A. Make sure you read a problem like this carefully, because the temptation to select B is there, but distinct means its own individual and unique number. That's not what we have.